right? So we have done the examples on the subspaces of R2, and so let's start with a few more examples, right? Question number 2 from 3.2, and that's what we have W, which is given to us, that is x1, x2, and so on, xn belongs to the Rn, or sometimes we call it as Vn or Rn, one and the same thing, such that your x1 is 0, right? So you need to show that it is a subspace of Rn or Vn, right? So if I'm talking about Vn or Rn, these are the same thing, okay? So you need to show that this set W is a subspace of Rn. So what does that mean? It means that the first component is 0. This is the first component, the first tuple of this set W is 0. We need to prove that whether it is going to be a subspace or not, right? So first of all, we know that it's a non-empty subset, right? 0, 0, 0, 0 is clearly belonging to the set. So now you pick two elements as we were doing. So let U, which is equal to x1, x2, xn, and V, which is equal to y1, y2, yn, belongs to the W. But what is the condition? The condition is if some element belongs to the W, so the condition is that the first tuple should be 0. So what we do, we directly replace this first tuple by 0. So that means, of course, these two elements belongs to the W. Now, see this. Now, what do you want to prove? If you are able to prove that alpha u plus beta v belongs to W for all alpha beta belongs to the real, then we are done, right? Yahi prove karna? This is the theorem which we have done.
Yes, sir.
Yes. Is this enough to show that W is a subspace? That means if you take alpha u plus beta v, so that will be alpha times the first element, which is 0, x2, x3, and so on up to xn, plus beta times the 0, y2, y3, and yn. So if you see that the alpha, if this alpha gets multiplied with this 0, this will be 0. And if this beta gets multiplied with this 0, this will be 0, right? So we are left with 0 alpha x2 plus beta y2, alpha x3 plus beta y3, and so on. The nth tuple will be alpha xn plus beta yn. So is it going to W? Does this element belong to W? Yes?
Yes, sir.
Yes,
Right?
sir.
Why? Because if you want to be the part of the W, the only condition is you should be n tuple and your first component should be 0. So that element is fulfilling this condition, right? So that means this first component is going to be 0 and all these are reals. So of course, this is a kind of element which belongs to W, right? So which means that W is a subspace of Vn, or you may call it as Rn. Yes. Is it fine?
Yes, sir.
Okay. Now see this. Now we have few examples from question number 4, where we'll be able to show that whether specific sets are forming subsets or not, right? So we need to choose the subspaces A part. And what does it says? You need to pick 3 tuple such that your x1, x2 is equal to 0. That means the product of first two element is going to be 0. Now, can you tell me, does it work? Is this going to be the subspace of V3 or R3? Yes. Now, if you take two elements from it, let's say I'm taking one element, that is U, and it is coming out to be 1, 0, 0. And I take another element that is 0, 1, 0. Now, if you see that, if you take the product of x1 and x2 in case of U1, so this is going to be 0. Yes, tell me.
Yes.
Yes, sir.
And similarly, if you take the product of these two in V case, that is also going to be 0.
Yes, sir.
So that means your U and V belongs to this set. Let me call it as W, belong to W. Now it will be a subspace of R3 if the addition and the scalar multiplication should also go to the W, right? So now if you take U plus V, so this will become 1, 0, 0 plus 0, 1, 0. So this will be 1, 1, 0. Now this time, if you take the product of these two, this is not going to be 0, right? So that means
Yes, sir.
U plus V does not belong to the W. Therefore, W is not a subspace of R3. So let me pick another question for you, that is, this time I take W in a way that x1, x2, x3 such that your x1 is an integer. Now, will this form a subspace or not?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
See, you have U, which is, let's say 1, 2, or let's say 1 root 2 and 3. Does it belong to W?
Yes, sir.
Now, if you take alpha is equal to root 2, so that means alpha U, which is equal to root 2 times the 1 root 2 and 3, this will become root 2, 2 and 3 root 2. So now you can clearly see this, that the first element is no longer an integer. So that means it does not belong to the W. That means W is not a subspace, right?
Yes, sir.
So that is something W is equal to x1, x2, x3 such that x1 square plus x2 square plus x3 square is less than 1. Will this be a subspace?
No, sir.
No, sir. No, sir.
Why is it not a subspace? Give me a good reason.
Addition में term 1 से बड़ी होती है.
हाँ, तो कौन से एलिमेंट उठाएं? So give me an example. Which elements I should pick in order to show that this will not hold?
There's some fraction.
Some point is
Okay. You tell me anything you want to.
Sir, U और V में अगर तीनों term 0.5 है.
हाँ?
सर वो U और V में अगर तीनों
हाँ.
term 0.5 हो, इंडिविजुअली तो वो बिलोंग करेगा, पर जब हम
Exactly.
U plus करेंगे,
Yes, sir.
0.5, 0.5, 0.5. Right? So if I have, in this case, I have half square plus half square plus half square. So this is going to be 0.75, which is going to be less than 1. Right? So therefore your U belongs to W. But if you take, let's say 2U, so this will become now 1, 1, 1. Right? And 2U will not belong to W. Why? Because 1 square plus 1 square plus 1 square is not going to be less than 1. Right? I mean, you can also do the addition property as well. I mean, this will also work. Okay. Let's say you pick some V, which is, let's say 0.5, and then 0, 0. That will also work. Now you take U plus V, so you'll have 1, 0.5 and 0.5. So clearly the square, sum of square is going to be greater than 1. So this will not be less than 1. So therefore U plus V does not belong to W. So you have so many ways to prove this. Okay. Now, what happens if I take the F part and that says what? It changes the condition with the thing that x1 plus x2 plus x3 is going to be greater than or equal to 0. Then will this going to be a subspace or not?
Sir, it may or may not.
See, either it will form a subspace or it will not. See, if some elements are obeying this condition, that doesn't mean that everything is nice. We want that every element should satisfy this condition. Only then we'll be able to say that that particular subset is a subspace or not. So may or may not should not be the word. Either it is a subspace or it is not a subspace. Even one such bad fish can restrict W to form a subspace. So if there is a bad fish, you'll simply say that W is not going to be a subspace.
Sir, when we'll multiply it by -1.
Yeah, that's it. It's very easy because alpha can have any value, right? So you pick U, let's say simply 1, 2, 3. But if you take alpha U and take alpha to be -1, so this will be -1, -2, and -3. Now this will not belong to the W. So therefore W is not a subspace. Is it fine? Yes.
Yes.
Yes, sir.
Okay, I tell you one more
Yes,
thing.
sir.
This is sort of bonus condition which I'm telling you. This is not a question from the book, I'm just giving you it, right? So let's say if the condition is x1 plus x2 plus x3 is equal to 4, then will this form a subspace?
No, sir.
No, sir.
Why
No,
is it
sir.
so?
No, sir.
Why is it so?
Sir, it will not satisfy the addition property.
दोनों ही addition ही scalar भी नहीं करेगा, right? So you take simply this thing and you take this thing, right? And now you take U plus V. So this will be what? 4, 4, 0. Now these two elements are falling in the set, right? But addition will not, because if you take the sum of these three elements, it will be 8. It will no longer be 4, right?
Yes, sir.
Yes, but if I change this condition, zero. Now, will this form a subspace?
Yes, sir.
This will definitely make a subspace. So all I want to point out is कि जब यहाँ पे if you are having something non-zero over here, it will never form a subspace. 4, 8, 12, whatever, because we'll choose these kind of tuples and addition will not belong to the set, right? But if it is 0 over there in addition, not in multiplication, I'm talking, right? So if it is 0 is over there, then the things will get satisfied, right? Because if you then you take alpha, sorry, then you take one element U, which is x1, x2, x3, and another element V, y1, y2, y3, with these conditions that x1 plus x2 plus x3 is 0, and here your y1 plus y2 plus y3 is 0, right? And now if you take alpha u plus beta v, so that will be alpha x1 plus beta y1 plus, sorry, alpha x2 plus beta y2, comma, and let me make some space, alpha x3 plus beta y3. Yes. Now you want to show that this also falls in W. So you take the addition of all three tuples. Now take alpha common and you have x1 plus x2 plus x3. Take beta common, you have y1 plus y2 plus y3. So now these two are zeros from here. So that means we can write it as alpha times 0 plus beta times 0. This is also going to be 0. So the linear combination is also falling in W. So that's why W is a subspace. Is it fine?
Yes, sir.
So whenever you get a non-zero number over there, this will not make a subspace in terms of addition, right? But when you get a 0, this will make a subspace. And in product, if you get 0 or non-zero, this is not going to be a subspace, as we have shown over here. And similarly, if you take squares, conditions with the squares, then also it will not be a subspace. Most of the time in addition, if it is equal to 0, then it makes a subspace, but most of the time, right? But if you are dealing with inequalities or let's say some non-zero constants, then most of the times the given set will no longer be a subspace. Fine, fair enough? So I'm giving you one exercise, that is question 4b. So I'm writing it over here. You need to prove, or you need to check actually, that whether this is going to be a subspace or not. Okay, so now let's talk about the subspaces. Another subspaces, this is somewhat degree of the polynomial. Okay, so what is that I'm gonna discuss? So I've also proved that the, let's say Pn is polynomials, all real polynomials of degree n. That means a0 plus a1x plus a2x square plus anxn. These are polynomial with degree n such that your an is non-zero. Because if your an is 0, then degree will be lower, right? Then degree will be to n minus 1. So in order to ensure that the polynomial is of degree n, what we are going to do, we'll assume that your an is going to be non-zero and all these constants are real. So these are, so Pn is what? It's a set of all polynomial of degree, all real polynomial of degree n, less than or equal to n, right? Degree less than or equal to n. Let's say you have a w, and w is a all polynomials, right? Call it as this p, right? In order to make the notation clear, I'll also call it as this p, such that degree of polynomial is going to be equal to 4. So will this form a subspace or not? That we're gonna check. सबसे पहली बात याद रखो, डिग्री लेस देन और इक्वल टू की फॉर्म में सबस्पेस बनता है, इक्वल वाली में सबस्पेस बन ही नहीं सकता, सिर्फ इक्वल वाली में. कैसे? You pick two elements, right? Let's say px, which is equal to this, and let's say you have qx, which is equal to this. So p and q are, px and qx belongs to w or not? Tell me.
They belong. Yes, sir.
Yes, because both have the degree 4.
Yes, sir.
Yes, sir.
But what happens if you add px and qx?
Degree 2.
Yes,
So
because the highest degree is having the opposite sign with the same amount, with the same magnitude. So we are left with x square plus x plus 4. Now this degree of px plus qx is what? Less than 4. So that means this does not belong to w. So therefore w is not a subspace, right? Yes. Are you with me on this?
yes, sir.
Okay. So see this. This is question number 5a, which I've done. Now let's say I'm doing the question number 5b. And that is what? All those polynomial having degree less than equal to 3. Now, can this form a subspace?
Yes.
This will definitely
Yes,
make a subspace. Now see this, what happens? So if you have, let's say px, this will be of the type a0 plus a1x plus a2x square plus a3x3. And now you pick qx, b0, b1x, b2x square, b3x cube, right? Your ai's and bi's are the real. Okay. Actually, an need not to be, right? So as I've told you, कि n होना जरूरी नहीं है. So all I want to say is degree of polynomials is less than equal to n. So ai can take any value, right? अगर exact degree n होगी तो वो subspace नहीं बनेगा. That's what I want to say. So there was a small error. I should write it as degree of polynomial should be less than equal to n. Okay, anyways. So now if you take alpha px plus beta qx, right? Then it will look like alpha a naught plus beta b naught, alpha a1 plus beta b1 times the x, alpha a2 plus beta b2 x square, alpha a3 plus beta b3 x cube. Now if you see that degree of alpha px plus beta qx, since all the constants are real, is also going to be less than equal to 3. So therefore, given set is a subspace of P. Yes. Is it fine?
Yes, sir.
Now I change the question a bit. So I write it as P belongs to the P. Degree of Px is greater than equal to 5. Now, will this be a subspace?
No, sir.
Why is it so?
Sir,
So
पिछले
because
question वाला
on this degree will not increase.
इसी तरह से ले लेंगे जैसे ये वाला क्वेश्चन किया है ना. In a similar way, we can write it as 5 over here. Okay. Yes. In a similar way, we'll take px and qx, and here we shall write 5 and 5. Then this will get cancelled, and degree of px and qx will be less than equal to 5, right? So that less than 5. So that, what does that mean? That means this set will not be a subspace, right? Will not be a subspace, right? ठीक है? So no matter if you are getting, right, if you are getting something equal to C, then and degree less than equal to C, or you may have degree greater than equal to C. So there can be 3 cases, right? Or more precisely 5, less than C, greater than C. So in this case, only this case, right? Only this case and this case will form a subspace. Okay, and rest of the cases will not form a subspace, right? These 3 cases will not form a subspace. Are you with me on this?
Yes, sir.
तो जब भी equal, greater या strictly greater आ जाए तो not subspace, but जब भी lesser आ जाए then subspace. So I'm leaving question number 6 as an exercise for you. You need to think that, and question number 5th E part. So this is an important set of questions. You must go through that exercise number 3.2. Okay. So if you want, you can go through and you can tell whether they are subspaces or not. Question number 5E. This is something like P belongs to P such that P at 1 is equal to 0. So will this be a subspace? Right? A polynomial which takes the value at 1 to be 0. In other words, 1 is the root of that polynomial. Yes.
Yes, it will.
Huh?
Sir, I guess it will, because P of 1 is equal to 0. So if we multiply तब भी तो 0 ही होगा.
वो तो हो ही जाएगा, मल्टीप्लाई से कोई प्रॉब्लम नहीं है, यहाँ पे स्केलर मल्टीप्लिकेशन है, एडिशन से कोई प्रॉब्लम है या नहीं है, दैट्स व्हाट आई वांट टू आस्क।
सर नहीं है, it will form subspace.
ये सबस्पेस बनेगा। If your P1 is 0, that means 1 is the root. So let's say if you take Px and Qx belongs to this set, let me call this as W. So if they belong to this, that means your P of 1 should be 0 and Q of 1 is also equal to 0. Okay? So now if you take Px plus Qx, right? And now think of P1 plus Q1. So if your P1 is 0, Q1 is 0, that means the 0 plus 0 will become 0. And if you take alpha P of x, that means alpha times P of 1. Now you check it at alpha times P of 1, not alpha Px, right? So that will also be what? Alpha times 0, which is equal to 0. So that means your Px plus Qx belongs to W and alpha Px also belongs to W. So that means what? W is a what? Subspace. Yes, are you with me on this?
Yes, sir.
If I put, instead of 0, if I put 2 over here, so will this make a subspace or not? Now this W is not going to be a subspace. So for this, consider this Px and Qx belongs to this W. So since Px and Qx belongs to W, so P must take value 2 at x is equal to 1 and Q must take value 2 at x is equal to 1. Now consider this Px plus Qx. Now if it belongs to W, it should take the value 2 at x is equal to 1. But what do you see? That if you put x to be 1, so it becomes 2 plus 2, 4. So that means your Px plus Qx doesn't qualify to be an element of W. So it doesn't belong to W. So therefore, W is not a subspace. So I want to point out the same fact over here. If the value of polynomial at some point is 0, then it's fine. Then most likely this will form a subspace. But if at some point the value is non-zero, then also most likely the W is not going to be a subspace. So that's it for today.